This video is about the Kotlin Analysis API. This is the first video in this series. In this video, I'm going to introduce you just to the basics, and this is more of a motivation on what it's about. So let's start by looking at what the Kotlin compiler does. What are the different phases? First, the Kotlin compiler takes your source code and it builds something called a PSI tree. This is the syntactic structure of your source. Each element represents an element in your source. Well, what it's missing is semantic information, and that's where the analysis part comes in. It takes a look at your overall code, the relationships between them, and it does type inference, and it adds semantic information to each of the elements. And there is an API which is provided in order to do this, and we're going to look at how that API works. This API was introduced in the K2 compiler, and it has benefits. It allows us to extend the analysis to be able to take Kotlin source code and convert it and translate it to Swift. So let's look at what information the semantic analysis provides us. The information it provides are things such as reference targets. It allows us to ensure the types for the expressions. It allows us to get information about scopes. When the analysis is performed, it has to take into account all the different scopes that are in your code, like global and local scope. It also allows me to get diagnostic information such as errors and warnings. So the analysis API takes a very wide approach. It looks at the relationships between your code in order to get this information. So the analysis API is behind all these IntelliJ features such as code completion, refactoring, and inspections. It's an internal API. So let's start by understanding what the semantic model of a piece of code is. So let's start with a simple example. I have a method add which takes in two parameters and it returns an integer. I also have a main method where I'm calling this method add and storing the result. So the first thing that has to happen is that we need to do type inference. We need to figure out what the type is for this result. And in order to do this, we need to take into account, what is the type that add is returning. So we need to take a step back and look at the relationships between our source code. So type inference is done during the analysis phase. The other thing we need to look at when we're analyzing this code, what the Kotlin compiler does is that it looks at our different scopes. I have defined two methods here in a global scope. I have the add method, which is in a global scope. I have the main method, which is also in a global scope. But internally, inside of this main method, I have a local scope defined. I have variables and symbols in this local scope. So the Kotlin Analysis API is able to analyze within different scopes. So the next thing, which is really, really important that the Analysis API gives me, are symbols. And these are symbols for each of the elements here. So I could get a symbol, for example, for this function, which is globally defined symbol. And then I also have here another globally defined symbol, which is main. When I get a symbol with the Kotlin Analysis API, it has methods to do resolution. It has methods to get the expression type. And that's something that's very, very useful with the Analysis API. The Analysis API also gives me symbols for my variables. For example, a variable such as a result, which is scoped locally. So the Kotlin compiler, once again, takes our piece of source code such as this, and it generates a PSI tree, which doesn't have a lot of information on semantics yet. This information is added during the analysis phase. So the analysis phase in the K2 compiler, in order to do this, it introduced a very simple analyze method, and which allows me to feed in some PSI element, and I could get semantic information to it. So the analysis API, let's start with a very simple example. Here I have a main method with a variable x, which has a value of 10. When I create the PSI tree, it looks like this. This is the syntactic structure of it. At the root, you always have a KT file. Each of the elements are prefixed with KT. And When you look at this closely, you'll see that KT property represents my variable, but the information that it doesn't have is a type reference, which is null. This is where the analysis API comes in. The analysis API looks at this, and when it does analysis, what I could do is take this reference expression, feed it to this API, and the API is implemented as extensions on these KT elements. So one of the extensions that the analysis API gives me is an expression type. And I could get the information, I could ensure that the type for the variable x is an int using the analysis API. So the way the analysis API is designed is that on top of these PSI elements, it provides me with extensions like expression type. It has providers for these extensions. So that's what the analysis API is, and we'll look at how that works with an example in the next video. We're going to look at an actual example and what that analysis method looks like. We'll look at various important constructs of this API, which are something called symbols and types, and internally they are called KA symbols and KA types. We'll look at two different ways to do the resolution is done. We'll also look at how do you get warnings and errors, diagnostic information. So I'll see you in the next video. I'll have the links to the videos in the description.